Okay. We're a nonprofit headquartered in Oakland. Like I said today, or like Sean started to say, I'm not going to talk about those other things, but I'm going to talk mostly about this EPIC grant that we are doing. And wow. Let's see. Huh. All right. So I'm going to give us an overview of the project, which our goal is to demonstrate the technical and economic potential for optimizing ZNE, but we're also including carbon. These are all electric buildings, are multifamily. What we're testing, like what's technically feasible in the field. What does that mean from a project design standpoint? And what does it mean for codes and standards? Yeah, these are the technical difficulties that I am not certified to.
And then I think for that, I think you have more help here. We're continuing to struggle with it.
Okay. Can I have you hold that, please?
So I'm just going to talk and then we'll get it. So I'll give you a brief overview of the project. I'll talk about how we're framing the goals, and I guess kind of spoiler alert, this is a little bit of a teaser. We've got a lot of data, and it's a lot of data that is in progress. So I'm not going to be doing a deep dive into the data and all the analysis because we're not there yet. So a lot of it's just about how we're approaching it and kind of what we expect. And based on what I've heard today, I actually have questions for you guys that I'd love some feedback on, and particularly like Mozzie. So, but that's towards the end. Push that button. That's more. Sweet. Okay. Okay. So as I mentioned, we want to demonstrate the feasibility of ZNE. These are all electric new construction projects. That bar is so funny. And this is just your summary here. So they're all low income. They're in 2 different climate zones, a range of 31 to 66 units. 3 of them are low rise, 1's mid rise or high rise, because it's 3 over a podium. And at this point, 3 of them are occupied, and 1 will be occupied September-ish. Your internet is unstable. Okay. Okay. This is not that. So we framed our kind of approach in a couple different ways. One is cost effectiveness, like when all electric construction, particularly with PV, is cost effective, and really looking at it from a domestic hot water standpoint, because that's one of the largest loads in multifamily. Code, we've heard a lot about code yesterday and today, and I'm super excited about what I heard from Mozzie and Martha, and that's awesome. So our goal is like, how can we continue to support that? Like they're stepping up and stepping out and kind of bring us in that direction, and we want to leverage this work to assist with that, so we can make sure we've got accurate values for these technologies. They're accounted for. And contributing to decarbonization. So Pierre just went and kind of brought us up here, and now I'm kind of like, our feet are firmly planted on the ground in this presentation, but very much tied up to those statewide goals of decarbonization and how we can compare those to a gas hybrid house or building. And I will say the other thing that we are finding us, oh, you can't read it, no think. Is Ted brought this up, is kind of like the marketing standpoint, but also I put it on the project team, right? That project design team, what kind of needs to be in place, what tools need to be there. So you've got the design, you've got the specs, because you'll see a little bit of what we're seeing out there is the intent or the goal is here, reality is here, which is different. And so moving forward to be effective, we need those to be more aligned. And I think our work can help us get there. I'm doing this one first and it'll catch up with me. And I know I have to totally be on time, don't I? Because Well, everyone does. These are our goals. I kind of talked about them. Looking at central versus individual. I'll show you how we're doing that in the next slide when we look at the systems. Combined versus separate systems. Electric versus hybrid. Sean mentioned thermal storage. We're looking at that as our water battery. And just that, you know, that balance, we've been hearing a lot about energy efficiency versus renewable. And I really like the way Anne-Marie talked about it in terms of this systematic approach, this whole system approach in terms of that efficiency and thinking about renewable. So you'll, okay, here we go. Really, I just want to kind of look at the domestic hot water side. These two columns here, it's good thing you can see that. So we have 3 of them that are central, and we have 1 that has individual systems. 2 of them have a combined DHW and space conditioning system, similar central plants. The other Atascadero there is an individual system, and our Sunnyvale project is a gang Sandon system. So we've taken individual heat pump water heaters, ganged them to create a central system, but that is providing domestic hot water only. So that's kind of our diversity of spread of projects. Pause. So the next slide is questions, and I don't expect you to read them, so I'll just go through them pretty quickly. But it helps to understand kind of how we're, what data we're collecting and how we're starting to look at it. So we're looking at water heating. You know, how does the efficiency of the system, of the equipment, and the plumbing distribution, how does that compare of central versus individual? How do we start making those decisions of when you want to put in a central plant versus individual? What kind of controls do we need in place? Storage, how can we use thermal storage? And so I've got this kind of test case that we're looking at, and I want to share that with you and would love your comments on that or questions. Code compliance, how can we make sure that we're accounting for them properly? And again, I mentioned kind of the energy use in ZNE design, which you can't see there. But what needs to be considered in the design stage and with the project team to overcome these market barriers. I'm going to skip ahead there. So there we go. So this next section I'm going to go through, I'm going to talk about 2 specific projects. It's the Calistoga and Cloverdale projects. Those were the 2 that had the central combined systems. I'm just going to show you a little bit about
Go ahead, keep going.
some of our data on the domestic hot water side and how we're thinking about it and what does this mean to the plant. And then also our electrical end use data. And I guess I kind of skipped the intro slide because I was talking but when it wasn't up there. But I just want to say I am representing the project team, but as Sean mentioned, he is on the project team, and so is Nehemiah Stone, and so is Nexi, and we'll see their equipment. So that's Lonnie Gaffman, who's here in Arcata, and Association for Energy Affordability, who is not here today. So I'm representing all of that amazing team. I'll say any mistakes I make are my own, not theirs. Yeah. And we have a number of awesome technical advisory folks, and one of them's in the room. So Sean is on our TAC. This is just a quick overview of the central system, right? It's got a central plant. It does heating, cooling, and water heating is provided by the AirMax, air to water heat pump chiller plants. So they've got 2 different loops, a cold water loop, a hot water loop, going to the units. And then there's fan coils in the units for space conditioning distribution. So they're intended to be, you know, super efficient. And having this, you know, combined simultaneous demand, when you have that simultaneous demand for hot and cold, and we'll kind of look at that. This next slide that's going to come up is just giving you a little bit of an overview or just kind of quick showing of what we're doing in Calistoga and Cloverdale. So we've installed monitoring equipment in phases throughout 2017. and even in through 2018 for both of those. We're doing data collection right now. We're cleaning it. We're starting to look at some trending data, which I'll show you. And then we're going to be doing retrocommissioning. So take these learnings from our trends and what we're seeing, figure out a retrocommissioning plan, implement that, and then evaluate, like, was that impactful? What happened? And how does that translate to design parameter specs, code, etc. 10 minutes. The next things that's just going to come up, you're not going to be able to read it at all, but just to give you a sense of, it's our monitoring diagram, like where all of our loggers are located, because what we're doing is our data includes flexible end use by the heat pumps and water pumps, water flow rates, water supply temperatures, return water temperatures, thermostat set points, etc. So we're getting a lot of data. Now I'm going to show you some. Let me just check my notes. Yeah, so I mean, I would say by studying all of these loads, whether it's like, you know, kWh, BTUs of it, the gallons per day, for hot and or cold, you know, we can compare the different loads of DHW and HVAC. We can look at the contributions of each of those compared to the total one, and we can evaluate, like, how is the system helping us get to a ZNE, which is what this building was designed to do. So we really want to understand the efficiency of this plant. And we can also compare it to unitary systems. This I have to wait for. So in conversations when we were out on site, one of the site managers at Calistoga was like, oh yeah, I've got my air conditioning running right now. And we're like, really, right now? Where we know other people were having heating. So just in conversation, we already knew we had the simultaneous mode happening. We just didn't know to what extent. So what you're seeing here is that there is simultaneous mode. So you can see where it is heating and cooling or cooling only. In our cases where it's heating only. And again, this is designed like optimally, right? You're getting your higher COPs when it's in simultaneous mode. What this graph is also showing you that you probably can't read here is what the COPs are. So roughly, when it's in heating only, it's 1.5 to 2.5. When it's in cooling only mode, so here, it's like 2.5, kind of consistently. And when it's in simultaneous mode, where it's supposed to be the most efficient, it's 2.5 to 6.3. What it is rated at, simultaneous mode, is 6.3. So overall, and then for heating only, it's 3.6, 3.2, and for cooling only, it's 2.63. The short of it is it's all performing lower than we expected. That's kind of our takeaway. Even in simultaneous mode, we're not seeing it consistently at that higher level. So what this is telling us is we need to start digging in to understand, like, what are the control mechanisms, what's distribution, what is happening that this is not performing at what it should be. Because our total efficiency rating is lower than what it should be. Yeah.
Look at if it's getting full load or is it just bad at part load? We can talk offline.
Yeah. I don't have time, but yeah. This quick chart, because the system operates in the 3 modes, and we just kind of did a calculation again to show the different COPs in heating only mode in this first column, cooling only, and then simultaneous in these bins of outdoor ambient temperature. And so I put in 2 tables. I probably should just put in 1. But this one is when chilled water is always happening. That's the way oh my God, that's the way the plant was designed. Sorry, I just looked at the time. Anyway, the short of it is it's underperforming. I'm gonna leave it at that.
Still learning more.
This again, what it's showing us is, like, we have really low delta T's. That is affecting our COPs up there. We are also,
Please explain what the delta T is.
I don't have time. Because I've got to get to this other stuff. So I have 5 minutes. We've got the secondary hot water pump always running. You can see in the second table right there. We've got the chilled water pump running a lot more than it should be. And so again, we're kind of looking at these numbers and it's not showing us what we would expect to see. So then we're starting to dig into why are we seeing these numbers. I'm going to skip the next slide. I will say with all of this information, what we're building right now is a retrocommissioning plan. So what we've started doing and what you guys are not privy to today is a number of those slides and kind of our hypotheses of the why and kind of what we're doing next, because we're just kind of not ready. We're not ready to share. We will be ready to share soon though. So that was on our domestic hot water side. This is on our electrical end use side. This is a Canary instrument. It's kind of designed in 2 ways. This data processing unit here is installed in the electric panel that you can see there. It is logging consumption there on the mains for the whole apartment, and then we identify specific circuit breakers. It also has a secondary function there with that lighting displays to give the tenant some indication of how much energy they're using. One side is for daily load, which is the right side. It's based on a budget. And then the other side is instantaneous use. So this, I'm just going to show you, go through these super fast. We have designed different monitoring for these 4 different projects. So we're monitoring different circuits. So we can start digging in more specifically on what the energy consumption, what the energy use is on multifamily for different circuits. This one project has 66 units, and we kind of created these different sample data sets. So we can try to paint this whole picture of plug loads, of kitchen and HVAC. The reason is we find out when we go into install these and figure out what we want to monitor, like, we need to talk to the electricians before they start like making the panel up, because we would like them to do it, you know, not combine all these different loads, because we have lighting and plug loads all together. The most discrete is the kitchen, but that's only because of the electrical code. And then even sometimes from unit to unit on the same project, it might be slightly different, which is enough to make you crazy. This is our last project here, Sunnyvale. And again, we're looking at 8 additional lines compared to the main. So we're in this particular project, because of the way the panel is, we're able to get almost all the circuits and consistent with each unit. So this diagram, just quickly, this is in Calistoga, 1, 2, and 3 bedrooms, you can see. So interesting anomaly. So we're seeing these, we're looking at trends. Anybody have any idea what that is?
Tell people what the access is. Up in front, you can see it.
Oh, this is July 2017 to May 2018.
Oh, that's fire.
Evacuated. Nobody was there. These, Thanksgiving, Christmas, New Year's. Those, which, now if I look at cooking, maybe these guys knew they were going to be evacuated and were doing lots of cooking before they had to go. I'm not sure. But these here, you can see kind of our cooking loads that we have, because that's one of the circuits we're monitoring, kind of align with that overall, larger overall picture. Next one is hourly. God, I'm so out of time, but I have to get to this other thing. One thing here, lots of data. There is some consistency in peaks, right? Morning peak, morning lull, early morning lull, but then also you see a lot of high users. Somewhere with a lot of those numbers, the average works out. Averages kind of work a little better in multifamily. But anyway, this is the kind of data that we're looking at and going to be disaggregating and evaluating to understand the energy use in multifamily. All right, so then this I really have to go quickly and do, because we're trying to test thermal storage. So we have made up this test to figure out how can we leverage the heat pump water heater to get us through the 5 to 9 peak. And this is where I need your thoughts, and then Mazi, I need data from you, I think. And we're looking at it in a couple different ways. So first is just how much water are we using, right? How much water do we have available if I'm charging somewhere in that 2 to 4 peak PV range? and I raise my hot water temperature to 130 or 140, how much available water do I have? And does that water get me through the 5 to 9? How does it help me out in the morning? I don't know yet. We don't know yet. So we're looking at that. We're also looking at energy consumption. So again, if we do this, we want to make sure that we're not increasing energy consumption at the end. We talked about electricity bills. We don't want to raise these bills. This is all affordable housing. And then for, Martha brought this up, but we also smart electrification, right? We don't want to be doing this and kind of using electricity at the dirtiest time. So how do we use it so it's not dirty? And then my question is, you know, we've done this analysis. This is hour of the day, kind of, you know, net offset, right? It's kind of carbon neutral for that day. But hearing Martha talk yesterday, it's not just that day. We want to know that hour. We're not kind of increasing dirtiness during the worst time. And so my question is, do we have an 8760 file of carbon that we can then use as we're doing our experiment so we can understand?
Yes. See, like there's all kinds of reports you can generate 8760 or by load for the entire year for carbon.
And I think, yeah, I think we just want like the CSV file so we can do it.
Do you have average and partial? No.
So the Energy Commission, the Public Utilities Commission has an embodied cost calculator available on site that gives you marginal emission factors for 2018 to 2046 every year.
Okay.
Where's that?
On the PUC website. It's called embodied cost calculator.
And is it a statewide average or is it regional?
Statewide average
Statewide.
marginal emission factors.
Yeah, what you're not going to get is a regional difference.
Yeah, you won't get the utility regional differences. So, but you know, that's enough because we are looking at this specific, and you know, we're designing this to be super. I mean, this test is very specific and apartment specific, but to be useful, we do have to raise it up and have a broader kind of standard that can be applied that we can give to Mozzie to apply statewide.
Yay!